it works is what we learn in this lesson. When we deploy our smart contract, we see a transaction in the log window. Let's open the details. Here we see three fields that are important: gas, transaction cost, and execution cost. Gas is relatively easy to understand. We have set a certain gas limit. We see this on the right. The actual costs are more interesting. Every transaction costs gas. This is dated in the Ethereum yellow paper and can be seen here. Can be seen in Appendix G fee schedule. Here you can see, for example, that G transaction costs 21,000 gas. So simply sending off a transaction already costs 21,000 gas. But now there are also other gas costs. For example, for G base, you have to pay 2 gas. For G balance, you have to pay 400 gas. But what does it mean? Let's jump into the debug mode of our transaction. And now let's look at the actual instructions. Let's open the menu. We see different instructions here. The instructions are divided into certain categories. For example, here's a push operation. In the yellow paper under Appendix H, you find which instruction belongs to which group. So push belongs, for example, to the group G very low, and this in turn costs 3 gas per instruction. That means these 2 push operations together cost 6 gas, and so on and so forth. Under step detail, you can see how much gas costs this just executed instruction and how much gas is left. The sum of all gas costs for each instruction is then the execution cost. But how does it differ from the transaction cost? Every single transaction has a specific base fee. This is true no matter what happens in the transaction. But then gas costs are also incurring when data is sent along. The amount of the cost depends on how much data is sent. In our specific case, we even create a new smart contract. Let's take a look at the situation in the yellow paper. So 21,000 gas for the transaction itself, then 32,000 gas for creating a new smart contract, and then 68 gas for each byte which is not 0, and 4 gas for each byte which is 0 in the data field. This is the data field. If you take all of this into account, then you get a certain sum. The transaction cost in Remix already includes the execution cost. Now this is how gas costs are calculated. But that's not quite over yet. How do you actually pay Ether for it? Or how do you get to this gas? And why pay in gas and not in Ether for that directly? This is very similar to driving a car. For example, the car consumes gasoline. Say like car A consumes 10 liters per 100 kilometers and car B consumes only 5 liters per 100 kilometers. Now, if the car A is driving in a country where the gasoline costs perhaps only 20 cents per liter, and car B is traveling in a country where the gas costs 40 cents per liter, then those 100 kilometers cost for both cars the same amount. That is, the gasoline consumption is only indirectly associated with the costs. If the gasoline were free, you would not pay anything for 100 kilometers, except the wear of the parts. The same principle applies to Ethereum. If you start a transaction in the real network, for example on the mainnet, then you always specify how many GUI per gas you want to pay. These costs are usually between 1 GUI and 100 GUI. The more you pay, the faster the transaction of minor nodes are processed and included in a block. If a large number of people start transaction at the same time, then there are many outstanding transactions in the transaction pool. But only about 15 transactions per 10 to 20 seconds can be processed. And to make that worthwhile for miners, they usually work on transactions that pay a lot for processing. Let's take a look at that in practice. To do this, I want to open myetherwallet.com. As you can see, there are several drop-downs on the top. One of them is for the gas costs. If you click on it, you can change the costs and the speed. These range from very, very slow, maybe fast, to fast. That depends on how much money you pay for each gas, and it always depends on how full the network is right now. One more thing I want to mention. You know now that every instruction costs gas, and how much gas is available is limited. This means that loops can quickly use a lot of gas, especially when loops scale with the number of users of the smart contract. Therefore, it is usually at least advisable not to use any loops unless you know exactly how often they are going through. So, enough theory for now. On to the next lesson.